everyone. Today, our group will be presenting you about projectile motion. So, what is projectile motion? Projectile motion refers to the motion of an object that is thrown or projected into the air and moves under the influence of gravity. These are the basic principles governing projectile motion. So, why do we choose these topics? First, to observe the change of initial velocity, angle, or displacement if one of them is being manipulated by using formulas in kinematics 2D chapter. Second, to apply the best techniques in real-life situations. So this is formula related to kinematics 2D chapter.
Projectile motion is a fundamental concept in archery governing the flight of arrows as they are released from the bow. Archers can adjust the distance they throw the bowstring and the duration they hold it before releasing the arrow to effect the angle at which the arrow is launched. Different angles will result in varying flying paths, affecting the arrow's ability to reach the target and score points. The initial velocity remains constant for a given bow and arrow setup. By controlling this variable effectively, archers can achieve accurate and effective shots, thereby improving their performance in the sport.
For question number 1, we need to find the angle of initial velocity and magnitude and direction of the final velocity. First, when displacement is equal to 50 meters, we can calculate out the angle of the arrow launched by substituting the value of time taken displacement between maximum height of the arrow from the ground (sy) and the initial velocity u, which is 57 meters per second. By using the angle, we can find the magnitude and the angle of the arrow just before it hits the target. Next, time goes to 70 meters. After found the angle of the arrow released, then we can find the magnitude and direction of the arrow just before it hits the target for 70 meters. The formula will be involved is motion equation to calculate ux and vx, uy and vy. Pythagoras theorem to calculate the resultant velocity, trigonometry equation to calculate the angle of the arrow.
Projectile motion is crucial in football, especially for passing effectively during a match. Adjusting the distance, kick, and the directions of the ball is in the air affects the ball's speed and trajectory. Players control initial velocity by manipulating displacement and time. Keeping the angle consistent while adjusting displacement and time optimizes passes. By controlling this variable effectively, players can increase the likelihood of delivering the ball quickly and accurately to their teammates.
Now we are calculating for the first. We got SS equal to 7.3 meter, time equal to 1.51 second, and angle we have 70 degree. To get US, we use the formula SS equal to UST. By using the value, we will get US equal to 4.83 meter per second. By using the value of US, we can calculate the value of U, which is 14.12 meter per second.
For the second kick, we will also find the initial velocity, which is U, using the same angle that is 70 degree, but different distance and time. First, we need to find the UX using the formula SS equal to UX times T, and we will get 4.49 meter per second. And then we find the U using UX equal to U cos theta, and we will get 13.14 meter per second for U. And last, we find the UY using U sin theta, and we will get 12.34 meter per second.
Projectile motion is relates to water rockets is the curved trajectory the rocket takes as it takes off and returns to the ground. Engineers can manipulate the rocket's trajectory and possibly extend its range by varying the launch angle and duration of the launch phase. When launching a water rocket, the main goal is to maximize displacement because this indicates how well the launch went and how far the rocket could travel. For whatever launch configuration, the rocket's initial velocity stays constant. Engineers are able to develop and launch water rockets that can go astounding distance by taking this aspect into account and understanding projectile motion.
In this case, we have to consider the initial velocity, thus we have to find the initial speed of horizontal motion and vertical motion. We have to use U at equal U cos theta. To illustrate, we know that the first angle used by student is 50 degrees. So we can substitute the information in the Ux equal 19.72 cos 50 degrees to get the initial speed of horizontal motion. We already informed that the time take is 3.08 seconds. Therefore, we can get the horizontal displacement of Sx by using the Sx equal Uxt plus half Ax squared. We can assume that acceleration is 0 meter per second squared, and we will get the derivative formula, which is Sx equal Ux times t elapsed. Now, left is we have to substitute the Ux that we found just now, 19.72 cos 50 degree, and multiply it by times elapsed, which is therefore we will get the Sx value, which is 39.04 meters.
So now, let us proceed to the angle of 60 degree. During the experiment, the period for rocket launch is 2.05 seconds. Sx is equal to Uxt. You just need to substitute all the value into the formula, and you get the answer is around 20.2 meter. Thus, the students should use the angle of 50 in order to get the maximum horizontal distance, so that the students could win the competition.
As a conclusion, our objectives have been achieved. After the experiment had conducted, it was found that when one of the factor was constant, the other remaining factors will be directly proportional to each other. So, we found the best technique to apply for projectile motion in football, archery, and rocket. That's all from us. Thank you.